So before we touch a single line of code or a single line of code for what we need to do and also the libraries, you need to understand what supervised learning actually is. Not just the definition, the intuition and the reasoning behind it. Because if you understand the intuition and reasoning, every algorithm we train later will make sense immediately. What is supervised learning? This is exactly what it sounds like. You are supervising the model by giving it examples, like here is an input, then here is an output. Let's see it as a child or anybody who is trying to learn something, and let's take a sample of a car. So we have X. Let's say, let's search for a car here. We have X, a car. Let's say we have another X, which is what? An airplane. We have another X, which is a bike. We have another X, let's say bus. So let's close this. So we have X as features and we have Y as labels. In machine learning, we call the features X and we call the labels Y. So anywhere you see it, like when you're trying to write a script, when you're trying to write a calculation for model, that is what you are going to see. So like I said, you provide like examples for this and you say, okay, this is a car, this is an airplane or a jet, this is a bicycle, and this is a bus. So you do this repeatedly, like you have several type of cars, several type of buses, several types of bicycles, several types of airplane or jets. So the model learns from those examples and then we ask it to predict output for the input it has never seen. So for example, now we have this as features and we have this as labels. We are going to have like a model. Let me just okay, let me try to make it as smooth as possible. We have this and we have the model in like this box to learn from that data. So what then happens is, for the model to learn, we have to label all this data now. We have to say, okay, for this now, for this also, we give it a label, and we also do for this. So we take this as a car, we take this as an airplane, we take this as a bus, we take this as no, this is a bicycle. We take this as a bus. So we provide several samples of this data for the model to learn from. So we provide several brands of cars, several model of cars. Like let's say Toyota, Honda. In Toyota, you can provide Camry, you can provide many other things. But there is an important distinction that I need us to clarify now, which is that we are in this series, we are not working with images of cars or images of planes or images of bicycle. We are working with characteristics, specifications of these features. So let's take, for example, let's have a table here. So we change this to, so let's say we call this fuel type. This is going to be a text. So let's say for this we have size, or let's say weight in kg. This is like, it's going to be a number. And okay, let's say we have this as passenger count. This is going to be also a number. Just these three examples. So what then happens is, For each of these, we take the characteristics. For the car now, let's say it uses gasoline. For the weight now, let's say it is just about 20,000 kg. Let's say it can pick 5 different people. So for the airplane, let's say it uses, let's say, jet fuel, for example. And it has about 79,000 kg. And this can pick about 120 people all at once. Then for the bicycle, it does not use any fuel, so we tag that as none or no fuel. And we have this with just like, let's say, 10 kg and can only pick 2 people or 1. So, and let's say for the bus now, this uses diesel with a weight of, like, let's say 40,000 and a passenger count of, like, let's say 25. So what then happens is that we collect this kind of data for each and every one of these things, and we then say we are going to have a label here, label, which is going to be text. So this would be car or automobile. This would be airplane. This would be a bicycle. And this would be a bus. So as you can see now, we have 3 main features. 3 main features for each row, for each transportation type, right? So, and we then say for if this is a gasoline, if the weight is 20 kg, if the passenger is 5, then it's a car. If the passenger is 7, it's a car, or something like that. So we have, let's assume that we now have about 1,000 rows of this kind of thing. So we might have about 100 rows that is car, like we can have 300 rows for bicycles, but they are of varying brand, which does not concern our data in this instance. However, we still have what we call neural network in machine learning, whereby instead of having to extract these features yourself, you take the images for the model to predict on, which is out of scope for this course. We'll be working with just structural data or structured data. So structured data is data you have in tables, while unstructured data is the one you have in, like, let's say, images, videos, audio, and so on and so forth. So every supervised learning problem has this structure. You have features, which are the inputs, and you have labels, which are the outputs, which you also know ahead of time. So, and the label is also the thing you want to predict. So the model learns from this mapping, so that the next time you come back here and take this kind of images, that was not in the data before. Let me move this. The model can predict. Let's let it predict here. Predict. Let me take this. And tells you that this is a bus. Yes. So that is a very, very interesting part. So in essence, right, supervised learning lets you to tell the model that this is what it should look like, so that when you provide unseen data, it can tell you what it is very, very fast. Supervised learning are split into 2 types based on the kind of label you are predicting. For example, you can say, or the problem can say, I need you to, or your manager can tell you that I need you to predict house prices based on this data set. So you know that for house price, you can have a house at $12,000. You can have it at $100,000. You can have it at $40,000. You can even have it as $1.2 million, and so on and so forth. Like, you have a continuous number of values. You have like an infinite number of values, right? That is when you know that you are working with a regression problem. This is what we call regression. So, and other samples of regression are like, let's say you are trying to predict. Let me take examples of regression. Other examples of regression is predicting crypto prices, cryptocurrency prices, predicting stock prices, predicting vehicle prices, and so on and so forth. We also have another kind of problem which we call the classification. So that means we have like a finite number of labels, not unlike the house price and the likes, that you can have varying amounts. So like even if what you are trying to predict is a number between 0 and 6, let's take you are trying to predict a die, and a die has numbers between 1 to 6, actually 1 and 6. So we are trying to predict something like that you know is finite amount of labels. Then you know you are working with a classification problem. For example, now you are trying to predict if an email is spam or no spam. Email, spam or no spam. Let me extend this. You are trying to predict if a customer will churn or not churn. You are trying to predict for cars or for, let's say, transportation means. You are trying to predict if it's a car, if it's a bus, if it's a bicycle, if it's a tricycle, and so on and so forth. Again, a finite amount of variables, and so on and so forth. So, again, in summary, classification is when you have like a set number of labels. No matter, even if you have 1 million rows of data, you still have a finite amount of labels. We can also talk about fruits. Either it's an orange, pineapple, banana, and so on and so forth. But for house prices, we are talking about something that is continuous, something that is finite or infinite rather. Something like temperature, and so on and so forth. The distinction matters because you will choose different algorithms, different loss functions, different evaluation metrics, depending on which type you have. We'll come back to this distinction in nearly every video. So in practice, your features are column in your data sets. Like we can see, we have a field type column, we have a weight column, we have a passenger column, and we also have a label column. So even though that is a label, but it's also a column. So let me just take this. This are our label, these are our features, and this is our label. Let me tag this and tag this. So feature and labels. So the question you are going to, one of the questions you are going to ask yourself when you are choosing the features you want to train your model with, because we'll eventually get there, right? But I want us to start building a mental model. In a case that you don't train your model with all data available in your data set, you don't choose all your columns as features. You need to ask some questions that this feature I'm about to use, right? Is it going to be available when my model is in production, when we want to get predictions? Questions like, is this feature important? Would eventually get there. So there are some steps we'll still have to carry out as we proceed in data preprocessing for us to determine, for us to ask the right questions when we are choosing our features to train the model. In part 2 of this, we will go deeper into concepts like overfitting, underfitting, the bias variance trade-off, and a tour of the algorithms we will be training in this series. See you there.